Welcome back to Chemical Kinetics. In this module, we are going to discuss some multiple choice questions based on the concepts that we have studied so far. So let's get started. Take this question. A graph is drawn between concentration of reactants on y-axis and time of the reaction on x-axis. The slope of the tangent drawn to the graph at a point corresponding to the reaction time t seconds gives option A, rate of the reaction, B, rate constant of the reaction, C, rate of the reaction at time t, and option D, half-life period of the reaction. In order to understand this question, let's draw the graph required. So we have to draw concentration of reactants versus time. Now we know that as the time proceeds, concentration of reactants is going to decrease, which means that my graph will look like this. Here if I take a point T on the x-axis and I plot its corresponding point on the graph, that's P. All I have to do is draw a tangent to it and find its slope. Now, doesn't it look similar to instantaneous rate of the reaction? What I am essentially finding out here is nothing but instantaneous rate. So look for an option which looks similar to instantaneous rate. And that is nothing but option C. Rate of the reaction at time t is nothing but the instantaneous rate. So the correct answer is option C. Let's move to the next question. The rate of a chemical reaction would it increase as the reaction proceeds? Or would it decrease as the reaction proceeds? Or will the rate of reaction increase or decrease during the reaction? Or will it remain constant as the reaction proceeds? Once again, in order to understand this, let's remember the graph that we have studied. This one right here. Rate of the reaction versus time. If you remember, the graph looks like this. If you can recollect, the rate of the reaction depends on concentration of reactants, and the concentration of reactants is going to decrease with time. So naturally, the rate is also going to decrease with time. So we know that as the time goes on, as the reaction proceeds, the rate of the reaction is certainly going to decrease, which means that the correct answer is option B. The rate of a chemical reaction would decrease as the reaction proceeds. Isn't it easy, my friends? Let's move on to the next MCQ. The rate of a reaction decreases with increase in. Okay, let's see what are the options. Concentration of the reactants, temperature of the reaction, time of the reaction, and with all the three above. Now, if you have really understood this question, it is very similar to the previous one. The rate of a reaction decreases with increase in. Well, you have the graph right here. The rate of the reaction decreases with increase in time. That is, as the reaction proceeds, the concentration of reactants decreases. Hence, the rate of the reaction decreases. So the correct answer is option C, time of the reaction. Let's move on to the next MCQ. The factor which does not influence the rate of reaction is option A, nature of reactant, option B, concentration of the reactants, option C, temperature, and D is molecular mass. Now, if you remember, it's a very straightforward question. Because if you remember, we had done factors which affect rate of reaction. and we encountered this concept over there. Concentration or pressure. Pressure is for gases. Temperature, nature of reactants. All these things affect the rate of reaction. Which means that obviously it is molecular mass which does not affect rate of reaction. So a very simple question this was. The answer is D, molecular mass. Let's move on to the next question. A catalyst increases the rate of reaction because it, and your options are, increases the activation energy, decreases the activation energy, decreases the collision diameter, or decreases the temperature coefficient. Lots of new terms involved over here. Collision diameter, temperature coefficient. But you don't have to get confused, because this is related to this concept right here that we have already studied. See, activation energy without a catalyst is more. What a catalyst does is that it decreases the activation energy, so the reaction takes place faster. It provides an alternate pathway of lower activation energy, if you remember. Which means that the answer is obviously B. A catalyst increases the rate of reaction because it decreases the activation energy. All these MCQs were really very simple. They are all concept based. Now in the next module, we will start with the concept of molecularity. Till then, take care.